It began with a color the universe rarely paints a blue, too vivid, too pure to belong to ice or dust. On October 29th, 2025, as the object called 3I Atlas curved around the Sun, a small chorus of telescopes across Earth watched it flare to life. In the cold calculus of astronomy, comets brighten, fade, and die with predictable grace. But this one burned differently. Its glow was not the warm gold of vaporized carbon or the pale silver of frozen methane. It was sapphire fire, an electric shimmer that glowed bluer than the sun itself. That moment carved silence into the control rooms. The readings from SOHO and the Solar Dynamics Observatory broke their normal rhythm brightness, increasing at a rate that violated thermal models, spectra bending toward wavelengths no known cometary material could produce. Astronomers stared at monitors where physics seemed to lose its footing. One whispered the word artifact, another malfunction, but the data kept repeating. The object had surged beyond explanation. ALMA's instruments, hundreds of miles away in Chile's Atacama Desert, caught something even more troubling. The coordinates no longer matched prediction. 4 arcseconds adrift, not much to the casual eye, but in the precision geometry of space, it meant a push from something unseen, non-gravitational acceleration. A phrase that tastes metallic when spoken aloud, because it implies an invisible hand. A comet pushed not by sunlight or jets of gas, but by something else, perhaps a mechanism, perhaps a mystery. The watchers gave it a new kind of attention. Theories collided in hushed conference calls. Residual outgassing, hidden fragmentation. Yet if that were true, Atlas should have shed a vast cloud of debris, billions of tons of glittering dust, now absent from every image. Space was empty around it, a vacuum too clean. The object accelerated without losing mass. The sun, ancient judge of all orbiting things, bent its light around the visitor. Avi Loeb at Harvard calculated the gravitational lensing effect, tiny, delicate, but measurable. Starlight deflected by a fraction of an arcsecond, enough to hint at density beyond expectation. It was as though the object's interior refused to conform to what comets are made of. Perhaps hollow, perhaps metallic, perhaps designed. For those attuned to cosmic omens, the date carried irony. Humanity, still arguing about its place in the universe, now stared at an emissary from beyond a third visitor after Oumuamua and Borisov, yet unlike either. Massive, swift, uncooperative with physics. A presence that seemed aware of its audience. News channels called it a comet behaving badly, but the name felt inadequate. Comet suggested something ephemeral, something doomed to die in sunlight. Atlas did not wither, it performed. Its luminosity rose and fell like breath. Observatories reported oscillations in brightness, rhythmic, almost deliberate. For a moment, imagination pressed against reason. In the public imagination, the blue flare became a symbol. Screens across the planet replayed that color, that impossible pulse. Artists rendered it as a cosmic eye. Poets called it a signal. Scientists, cautious and weary, published numbers instead. Luminosity ratios, polarization data, angular deflection. Yet even they could not hide the tremor beneath their words. Because in that shade of blue was a question older than science. Are we alone? And if not, would we recognize the greeting? Atlas crossed its perihelion, trailing no familiar plume, leaving behind equations undone. Its path curved outward toward Earth's orbit, scheduled to make its closest pass in December. Between now and then, the world would watch, measure, and debate. But for that single day in October, all speculation dissolved into awe. A point of light, 4 arcseconds adrift, whispered that our maps of reality might be slightly beautifully wrong. It began as so many cosmic revolutions do, in silence, a pulse of data scrolling across a screen at an observatory half buried in snow. Months before its blue flare unsettled the world, 3I Atlas was only a faint smudge in the endless sky. It was discovered not by the naked eye, but by an algorithm, one of those tireless watchers trained to find the faint motions that betray a wanderer among the fixed stars. It was early 2025. The Atlas Survey Asteroid Terrestrial Impact Last Alert System had been scanning for near-Earth objects, those tiny bodies whose trajectories might one day cross ours with violent consequence. Its mission was vigilance, not wonder. But wonder has a way of sneaking through the back door. The telescope on Mauna Loa caught a peculiar streak, faint, fast, and angled unlike any asteroid expected to pass so near the Sunday. The initial report filed by Dr. Kailia Sato, one of Atlas's duty astronomers, sounded almost routine. New transient object detected, approximate magnitude 18.7, moving retrograde relative to ecliptic. But beneath the cool precision, a spark of unease lingered. The motion was too sharp, the velocity too high. Cross-checks with the Pan-STARRS database returned nothing. When trajectory calculations were run through the Minor Planet Center, the results drew a thin line that didn't close a hyperbolic arc. The object was not bound by the sun's gravity, it was visiting. Word spread through the international network of observatories like static before a storm. Within hours, confirmations arrived from Chile, South Africa, and Spain. The orbit was hyperbolic indeed, with an eccentricity greater than 1.1. That single decimal point, so small, so indifferent, meant everything. Atlas was not from here. Journal papers take months. Excitement takes seconds. By the time NASA's Jet Propulsion Laboratory verified the data, astronomers were already calling it the third interstellar object ever detected, after Oumuamua and Borisov. A lineage was forming, a sequence that suggested the galaxy was sending samples messages in the form of motion. But the discovery itself carried a mood unlike the two before. Oumuamua had been elusive, visible for mere days before fading. Borisov had been a comet in the most traditional sense, a glowing, icy traveler. Atlas, by contrast, was massive and brilliant. Early radar estimates placed it at nearly 100 kilometers across, large enough to crush a city beneath a single shard if it were ever to strike. Of course it wouldn't. Its course was outbound, interstellar again, but not before a long, intimate waltz with the Sunday. Astronomers named it formally 3I Atlas. 3I for the third interstellar object, Atlas for the system that found it. But even as the name settled into academic notation, the object refused to behave like a statistic. Its albedo was unusually high. It reflected light, like polished metal, not dusty ice. Spectral analysis from the Subaru telescope hinted at complex absorption lines, possibly nickel-rich, that raised eyebrows. Nickel is heavy. It doesn't like to form the fluffy aggregates of typical comets. It sinks, it solidifies. Dr. Sato, revisiting her data, wrote in her log, "There's something unnervingly deliberate about its motion." At first, the phrasing was dismissed as metaphor, but within weeks, that sense of deliberation would become the story's quiet undercurrent. The more precisely scientists plotted its orbit, the less random it seemed. The trajectory entered from the direction of Sagittarius, a corridor of sky haunted by the faint memory of the wow signal of 1977. A coincidence, yes, but one that threaded through the scientific subconscious like a needle of unease. By mid-2025, observatories around the world had turned toward it. The European Southern Observatory used VLT to capture its surface polarization. The Arecibo Replacement Array, still young, tried bouncing radar off it. The return was weak but coherent, too coherent, some said. It's as if the surface is smoother than we expected, noted one scientist on an internal call. Like ceramic, not rock. The data was real. The object was there. And yet, even the coldest instruments seemed to record something more than coordinates. A whisper in the noise, a hesitation between numbers, as though the universe itself were uncertain what to call this thing. By the time the first press release reached the public, the story had already begun to stretch beyond science. News anchors spoke of an object from another star system entering our own. Artists rendered it as a glowing shard slicing through starlight. Children, peering at the evening news beside their parents, learned a new word, interstellar. But beneath the headlines, in labs and universities, the atmosphere grew tense. If this object was truly interstellar, if its size and trajectory were accurate, then its origin story would test everything astronomers knew about planet formation. How could something so large escape its home system's gravity? What kind of event could launch such a titan across the void? And why, when the odds were billions to one, did it come to pass near Earth's neighborhood? In the first weeks after discovery, the excitement was pure. Telescopes competed to lock onto it before dawn washed it away. Photometric curves built like symphonies. Every observer felt a strange intimacy with it, an awareness that they were watching something that had never belonged to our Sunday. Then came the first anomaly, the trajectory's uncanny precision. Even in the early datasets, Atlas's path aligned within 5 degrees of the solar system's ecliptic plane. No one expected that. Most interstellar objects tumble in from random angles, obeying the chaos of the galaxy. This one slipped into the sun's equatorial dance as if it knew the choreography. Chance, perhaps. But chance repeated begins to resemble design. For now, though, it was just a discovery, a data point in the ledger of the cosmos. The astronomers named, measured, and catalogued it as they always had. But some, secretly, wondered if history would remember this night not as the detection of a comet, but as the moment humanity first glimpsed evidence of something else, something watching, or perhaps simply passing by, indifferent to our wonder. The coordinates were logged, the name recorded, the sky turned, and Atlas continued its long fall toward the sun, unaware or perfectly aware that a civilization now watched its every motion. Before Atlas, the universe had already whispered twice, once in 2017, again in 2019. Both times, humanity caught a fleeting glimpse of something alien, not in form perhaps, but in origin. These were not ships nor signals, but silent stones, crossing our solar system from interstellar night. And each arrival had left a mark, a widening fracture in our understanding of what drifts between the stars. The first was Oumuamua, a slender traveler that came from nowhere and left every theory gasping. It was discovered by Pan-STARRS, the vigilant sentinel atop Haleakala, in October 2017. At first it looked like any other asteroid, but its trajectory was hyperbolic, its speed excessive, its origin unknown, and its shape, oh, its shape. Calculations suggested a long, cigar-like body, perhaps 10 times longer than wide, or maybe a flattened shard, thin as a sail. It tumbled irregularly, its brightness oscillating like a rotating mirror, no coma, no tail. And yet, inexplicably, it accelerated as it left the sun. Non-gravitational acceleration, an echo of what we would one day see with Atlas. At the time, most dismissed it as outgassing too faint to detect, but the numbers never quite fit. The equations bent, and so did our certainties. Then came Comet Borisov in 2019, a second visitor, natural and proud of it. Borisov behaved like a textbook comet, spewing gas and dust as it neared the sun, its tail a silver thread of familiarity. It reassured the skeptics. See, interstellar comets can exist. The cosmos had thrown us a bone carved from ancient ice. We studied it, and we exhaled. For a while, the mystery rested. The anomaly of Oumuamua became a scientific ghost story still debated, but quietly folded into history, until Atlas arrived. When the first orbital parameters were plotted, a collective shiver ran through the astrophysical community. It wasn't just that Atlas was interstellar, it was that it defied the statistical patterns suggested by its predecessors. Oumuamua had been small and fast, Borisov, smaller still but slower. Atlas broke both rules. It was massive and swift, a contradiction that made natural formation almost impossible. If the galaxy had dice, this role would never occur twice in the same century. Atlas was, by sheer scale, a cosmic leviathan. If Oumuamua were a pebble tossed into the ocean, Atlas was a drifting island, 1,000,000 times more massive than the first, 1,000 times larger than the second. And yet, its path was not random chaos. It entered from beyond the heliopause like a messenger, tracing the same invisible lane through which Oumuamua once glided. For some, it was a pattern, for others, a coincidence. But to those attuned to the language of probability, it was as though the universe had begun to clear its throat. Dr. Avi Loeb, who had already endured the storm of criticism for suggesting Oumuamua might be artificial, watched the Atlas data unfold with restrained intensity. "If this pattern continues," he once told an interviewer, "then we are witnessing a sequence, not an accident." His colleagues frowned. Science dislikes sequences born from emotion, but Loeb had a memory long enough to feel the echo an object that accelerates without visible outgassing again. Oumuamua had challenged our physics. Borisov had restored our comfort. Atlas now threatened to take both away. In laboratories and observatories, the stories of these three visitors began to intertwine. Comparative models were built, showing mass, albedo, eccentricity, and acceleration plotted on logarithmic scales. Oumuamua drifted far from expected cometary norms. Borisov sat comfortably in the curve. Atlas shattered the graph entirely. It was like comparing a whisper, a sigh, and then a thunderclap. The more scientists studied the lineage, the clearer it became. Atlas was not simply another interstellar object. It was an escalation. Each visitor had pushed further into the impossible. Each had expanded the perimeter of what we dared call natural. In the halls of academia, words like technological artifact remained taboo. But late at night, in the glow of screens, some whispered them anyway. If the first was a scout and the second a reassurance, what was the third? A signal? A continuation? A test? The speculative thought hovered, unspoken but alive. Perhaps these were not three separate discoveries at all. Perhaps they were three acts of a single story, still unfolding, a slow revelation written across years and parsecs. When compared in spectral data, another peculiarity emerged. Atlas shared faint metallic absorption lines with Oumuamua, weak traces that could hint at nickel or iron compounds uncommon in frozen bodies. Borisov, true to its cometary nature, showed none. The contrast was striking. It was as if nature had composed one verse, then someone or something had rewritten the next in a different tongue. The public, fed by headlines and speculation, began to romanticize it. Documentaries called them the messengers. Forums debated if they were probes, if they were pieces of lost civilizations, or if they were simply accidents that we had inflated into omens. But beneath all the noise, one truth persisted. The data was real. The universe was sending bodies from elsewhere, and we were learning, slowly, that the cosmos might be more connected than we had dared to imagine. For decades, we had watched the skies for radio signals, expecting language, structure, intelligence in photons and waves. But maybe, the visitors implied, the universe speaks first in motion. Objects, not words. Trajectories, not tones. Atlas, in this lineage, was a crescendo, a body that not only crossed the stars but also bent the laws that once held our faith. By the time it neared the sun, the echoes of Oumuamua and Borisov had become background music, a haunting melody that made every new observation feel like déjà vu. Humanity, it seemed, was no longer just a spectator of the cosmos, but a participant in a story whose first line had been written long before we had eyes to see. And somewhere, in that vast emptiness between stars, something or nothing at all was writing the next chapter. In the cold, mathematical stillness of orbital mechanics, probability is the only poetry. Every celestial body moves according to rhythm, a waltz between mass, gravity, and time. Yet, when astronomers traced the path of 3I Atlas, the equations whispered something uncanny. This was not choreography born of chance. It was precision masquerading as chaos. The data was incontrovertible. Atlas entered the solar system on a retrograde trajectory, moving against the current of the planets, threading upstream through their ordered revolutions. That alone was strange but not impossible. Nature occasionally rolls such dice. But Atlas's trajectory was aligned within 5 degrees of the ecliptic plane, the thin, invisible sheet upon which every planet, asteroid, and comet performs its endless dance. To arrive from interstellar space and still align so neatly with the solar system's flattened geometry defied statistical expectation. Imagine, one astronomer remarked, shooting an arrow backward through a hurricane and striking the center of a spinning coin miles away. The odds were less than 0.2%, a cosmic miracle of precision or a gesture of intention. The discovery spread through the observatory networks with the unease of a whisper. Computer simulations confirmed it again and again. This was no random plunge from the galactic wild. Atlas had entered on a path that mirrored the planetary stage as though rehearsed. Some tried to downplay it, perhaps. Gravitational perturbations from unseen interstellar clouds had gently steered its course. Perhaps coincidence was simply flexing its infinite muscle. But others saw in the numbers a symmetry too elegant to ignore. For centuries, celestial mechanics had been humanity's most reliable compass, immutable, predictable, serene. Newton's law of gravitation, Einstein's curvature of space-time, the grand mechanics of celestial bodies obeying the silent pull of the Sunday. Yet here was a body that seemed to know where our planets lay, slipping perfectly among them, as if tracing the grooves of an unseen map. As astronomers ran the trajectory backward in time, the path dissolved into the galactic dark, its origin impossible to pin down. Unlike most interstellar visitors, whose journeys can be traced to nearby stellar neighborhoods, Atlas's vector pointed toward the Sagittarius region, near the galactic center. It came from a corridor of the Milky Way, dense with radiation and ancient stars, a place where gravitational tides twist orbits like ribbons. That was strange enough, but the exact coordinates struck another chord of familiarity, within 9 degrees of the WOW signal direction. Coincidence again, perhaps. Yet the cosmic coincidences surrounding Atlas were piling into a pattern, like footprints, too evenly spaced to be random. When visualized through simulation, Atlas's path resembled a needle threading through the solar system's tapestry. It skimmed the orbit of Jupiter, brushed the plane of Mars, and passed within sight of Venus, not colliding, not disturbing, but gliding, synchronizing. Every planetary encounter carried timing so perfect that one astrophysicist called it an orbital ballet. Probability, that old guardian of reason, was losing its grip. To comprehend the strangeness of that alignment, Consider the chaos of galactic motion. Our Sun orbits the Milky Way once every 230 million years. Interstellar objects, ejected from their parent systems by violent gravitational encounters, scatter across space in random trajectories, their inclinations spanning every conceivable angle. For one of them to enter the narrow plane of our own planetary system, and to do so in reverse, is like tossing a grain of sand from another beach and watching it land in the groove of a seashell. Even Avi Loeb, a man no stranger to cosmic controversies, hesitated before the numbers. If it were purely random, he noted, we would expect thousands, millions of different possible orientations. This one chose the ecliptic. That's not something to dismiss lightly. Others countered that natural explanations could exist. Galactic tides could focus trajectories over vast timescales. Perhaps the Sun's gravity had subtly bent Atlas's incoming vector, funneling it toward alignment. Yet even those models struggled to reproduce the exactness observed. Each simulation ended with deviations larger than what the telescopes recorded. It was as if the object had adjusted itself. That notion adjustment lingered uncomfortably, because adjustment implies control. Control implies design. And design, in the realm of astrophysics, is a word too heavy to speak aloud. Still, the hypothesis grew in the quiet corners of thought. Some imagined Atlas as a derelict craft, its trajectory the fossil of an ancient intention. Others proposed a natural but extraordinary cause. Perhaps it was part of a debris stream, remnants of a shattered world expelled in unison, maintaining their shared plane across light years. The galaxy, after all, is old enough for such accidents. But there was more to the trajectory than alignment. When examined near perihelion, it deviated not in a chaotic way, but subtly, gracefully, by those 4 arcseconds detected by ALMA, a deviation that suggested not error but correction, as though Atlas were fine-tuning its path in response to the Sun's pull. For a moment, the scientific imagination faltered. The comparison to Oumuamua deepened the unease. 2 interstellar objects, both showing non-gravitational acceleration, both unexplained by outgassing. 2 arrows bent slightly mid-flight. 2 messengers altering course just enough to be noticed. The world's telescopes turned to follow. NASA's orbital models updated daily, their error bars shrinking, then inexplicably widening again as the data refused to settle. The path ahead grew mysterious, a sweep past Earth in December 2025. Close enough for direct observation, close enough for questions to demand answers. And so, in the stillness of calculation, astronomers found themselves staring not at numbers, but at intention disguised as coincidence. The path of Atlas cut across the solar system like a sentence written in an unknown language, geometry as grammar, precision as punctuation. No one knew what it said, but everyone could read the rhythm. A retrograde orbit, a perfect plane, an impossible aim. If nature had thrown this dart, it had done so with godlike accuracy. And if not nature, then someone, somewhere, had written the first line of a dialogue we were only beginning to hear. Through the long summer of 2025, as the sun burned steady and indifferent, astronomers watched Atlas transform. It was expected to behave like every comet before it, a frozen relic thawing under solar warmth, exhaling gas and dust into a bright, sweeping tail that would stretch away from the star. This is the oldest rule of cometary behavior. The sun pushes, the comet yields. But Atlas did not yield. It resisted. It did the unthinkable. Between July and August, observatories across the globe recorded a strange and precise phenomenon. From the object's surface, or whatever structure resembled a surface, a jet erupted, narrow, coherent, and sharply defined. It did not arc away from the sun like a normal outflow. It pointed directly toward it. For centuries, Physicists had taught that solar radiation and the solar wind always sculpt a comet's tail in the opposite direction of the Sunday. The pressure of photons, the charge of particles, these forces dominate even the most massive comet nuclei. But Atlas violated that symmetry as casually as a poet ignoring rhyme. It generated an anti-tail, a lance of light and particles aimed at the very source of heat that should have repelled it. The data was irrefutable. SOHO and stereo satellites captured ultraviolet imaging showing a structure projecting sunward straight, unwavering, stable for days. The spectroscopic profile of the emission was unprecedented. It was not water vapor, nor carbon monoxide, nor any known volatile. Instead, it contained traces of ionized nickel and silicates, materials that should not sublimate easily, much less form a coherent jet against the torrent of solar radiation. The discovery was so bizarre that the first reaction was denial. Instruments must have glitched, image orientation must be reversed. Yet as independent confirmations poured in from Chile, Japan, and the Canary Islands, denial gave way to wonder. The images were real, the direction was precise, the anti-tail existed. For many, this was the moment Atlas ceased to be a curiosity and became a crisis. The anti-tail didn't merely contradict existing models, it mocked them. To produce such a jet naturally, a comet would need a heat source on its far side, away from the sun, or a form of outgassing so powerful it could overcome the relentless push of solar wind. But no rotation, no thermal asymmetry, could explain such constancy. The jet didn't flicker, it didn't spiral with the body's rotation. It remained locked on target, unwavering, deliberate. When the first detailed analysis arrived from ALMA, its authors chose their words with surgical care. The object exhibits sustained collimated emission directed sunward with no evident rotational modulation. Translation: it was as if the object was firing something at the Sunday. Some speculated it could be electromagnetic in nature, perhaps a plasma interaction between a metallic surface and the solar wind, generating currents that expelled charged particles in a directed beam. Others imagined dust grains being pulled inward by an unseen magnetic field, sculpting an optical illusion. But the models stumbled. Every simulation required parameters that nature doesn't provide. And then came the strangest observation of all. The jet's intensity varied in synchronized pulses at intervals of roughly 30 minutes, like a heartbeat or a signal. Radio observatories tuned in, half in jest, to search for modulation. They found nothing but static, at least, nothing recognizable. Yet that rhythmic flicker haunted those who watched the graphs. It was not chaos, it was cadence. For Avi Loeb, the anti-tail rekindled the spark of heresy that had once made him infamous. He proposed cautiously that artificial propulsion should not be excluded from consideration. If you see a sail, he said, it is wise to ask whether it catches light or makes it. His remark was met with predictable resistance. Critics accused him of sensationalism, but deep down, many knew that the anti-tail had no easy refuge in known physics. What if, some dared to ask, Atlas was not resisting the sun but communicating with it? The sun, after all, is not silent. Its magnetic fields roar, its plasma waves hum through space like the strings of a cosmic instrument. Perhaps the jet was a response to that song, a resonance, an attempt to balance the energy it absorbed. Some astrophysicists proposed that Atlas might be composed of exotic material that interacts with radiation in non-linear ways, materials that could, under intense solar bombardment, emit counter-streaming flows of ions. The idea was radical but at least not mystical. Still, one detail refused to fit: the directional stability. No known natural process could maintain such a fixed orientation for weeks. Not even gravitational torques could counter the chaotic tumbling typical of cometary bodies. Whatever Atlas was, it possessed balance. A quiet awe settled over the global network of observers. Data flowed in daily. Each new measurement deepened the riddle. The antitail remained, thin as a filament, bright as defiance. By late August, as Atlas drifted closer to its perihelion, the jet faded not explosively, not like a comet shedding its outer shell, but smoothly, as if throttled down. Its cessation was too controlled to be collapse. The emissions simply ceased, leaving behind an object eerily unchanged. In that silence, the sun reclaimed its dominance, but something had shifted in the hearts of those who'd seen the anomaly. It wasn't just a tail or a beam or a trick of light. It was the feeling that the object had responded not to us, but to the sun itself, as though it had completed some private exchange. When the last of the August data was logged, the astronomers could only stare at the graphs, straight lines where curves should be, pulses where noise should reign. It was there, written in the numbers like a riddle whispered by fire. A body of unknown origin had pointed its light against the source of all light. And, for a brief and beautiful moment, the universe had stared back. In the arithmetic of the cosmos, mass and velocity are not lovers meant to dance together. The heavier an object, the slower it tends to move, bound by inertia, enslaved to energy conservation. But Atlas broke that sacred bond. It was both colossal and swift, a contradiction that made even seasoned astrophysicists feel a tremor in their faith in physics. Early estimates from radar and photometric data hinted at something extraordinary. The object was enormous, spanning perhaps 100 kilometers across a mountain adrift between stars. That alone made it one of the largest interstellar bodies ever observed. Yet, despite its vast bulk, Atlas raced through the void at over 110 kilometers per second, faster than most comets, faster than any comparable body known to science. For context, that's nearly 4 times the speed of Earth's escape velocity. At such speed, space itself becomes viscous, resisting motion with invisible tides of gravitational energy. In the language of probability, this combination of scale and velocity was an impossibility less than 1 in 1,000. Imagine a freight train hurtling faster than a bullet, carrying the weight of continents, and doing so without apparent effort. The numbers refused to cooperate. Astrophysicists began to retrace the equations that govern celestial motion. The standard models of object ejection from stellar systems, planetary collisions, gravitational slingshots, supernovae disruptions could produce interstellar wanderers. Yes, but not like this. To achieve such speed, Atlas would have required an initial energy so vast it bordered on absurdity. Even the cataclysmic birth of neutron stars, those cosmic anvils of violence, rarely fling debris at velocities so high. Some proposed that perhaps it had been accelerated gradually, propelled over millennia by radiation pressure or gravitational interactions with multiple stars. But that, too, would demand a delicate choreography of cosmic coincidences. Atlas did not seem the child of chaos. It was the portrait of precision. As data accumulated, the metaphors grew bolder. One researcher described it as a skyscraper surfing the galactic wind. Another whispered, "If it's natural, it's a masterpiece." The brightness models deepened the mystery. Despite its vast size, Atlas reflected more light than expected, suggesting a highly reflective surface, perhaps metallic. This, combined with its immense speed, painted an unsettling picture. A massive, gleaming object slicing through interstellar space as if designed to endure the frictionless eternity between stars. If Atlas was truly metallic, that alone demanded redefinition. The formation of such a dense, reflective body outside the solar system, capable of surviving eons of cosmic radiation, would imply geological processes unlike anything we understand. and if not geological, then technological. Still, the guardians of skepticism held their ground. Maybe, they argued, Atlas was the fragment of a planetary core ripped from a dying world and polished by collisions over billions of years. The metallic sheen, they said, could be natural, forged in the furnaces of supernovae, but even that could not explain the speed. The math refused to settle. Gravitational simulations run at JPL and the European Space Agency attempted to reconstruct its journey. If traced backward far enough, Atlas seemed to come not from the direction of any nearby star, but from deep within the Sagittarius arm of the Milky Way, perhaps tens of thousands of light-years away. For an object of that size to travel such a distance without being slowed or destroyed, it must have been traveling for millions of years, a voyage older than humanity itself. Yet its surface, as observed through spectral albedo, appeared relatively unweathered. Interstellar radiation should have darkened it, scarred it, pitted it with cosmic dust impacts. Instead, it gleamed, as though shielded or self-repairing. That observation spawned its own branch of speculation. Perhaps Atlas carried a magnetic field, faint but persistent, deflecting charged particles. If true, that would make it not a passive relic, but an active entity, a survivor with defenses. A few dared to imagine further. What if the speed was not the aftermath of chaos, but the result of propulsion? If radiation sails can be built on Earth, thin films of carbon or aluminum accelerated by sunlight, then why not on a scale beyond comprehension? Could Atlas be a vessel propelled by a mechanism long silent but still coasting on momentum? The notion was wild, but so were the facts. To compare, a natural comet typically travels 30-70 kilometers per second. The fastest known asteroids barely exceed 90. Atlas not only surpassed them all but did so while carrying the inertia of a small moon. Its momentum was a declaration. Whatever force had launched it, nature's normal engines were insufficient. Dr. Elara Nystrom of Uppsala Observatory expressed it in a single sentence that echoed across scientific circles. Atlas moves as though it remembers being pushed. The phrase lingered. It implied memory, and in a way, perhaps Atlas did remember. Its path, its rotation, its glinting skin, all told a story of an origin far stranger than we could guess. Some even speculated that the object might not be solid at all but a hollow structure, vast yet light, its apparent density misread. That would explain both the velocity and the reflectivity, an immense shell rather than a solid rock, coasting through space like a lantern adrift on an eternal wind. If that were true, then the implications were monumental. A hollow, metallic, reflective interstellar object of enormous scale and stability would border on proof of engineering at a level beyond our own history. And yet, in the cool tone of scientific caution, papers continued to describe it as a highly anomalous cometary body. The language was a mask. Beneath it, the question was raw and unspoken. What kind of natural body behaves like intention itself? As autumn crept toward perihelion, the numbers solidified. Atlas was not slowing. Its path was steady, its speed unrelenting. It cut through gravity like silk through water. The sun's pull barely grazed it. It was as though Atlas had already learned the rules of the universe and chosen which ones to obey. By late September, the rhythm of Atlas's voyage had begun to reveal something eerie, something too precise to ignore. Its path through the solar system was not only improbable in direction, it was synchronized, as if the heavens themselves were keeping time to its passage. One by one, the planets turned to meet it not through chance alignments, but through a choreography so exact it left even seasoned celestial mechanicians in stunned silence. Within a span of weeks, Atlas would pass within close observational range of Mars, Venus, and Jupiter, while remaining almost perfectly invisible from Earth at the crucial moment of its perihelion. To achieve this configuration through random cosmic motion carried a probability of less than 0.005%. 5 chances in 100,000. Imagine throwing 3 darts into the night and having each strike a different moving target, while a 4th dart, thrown blindfolded, misses the observer's line of sight by millimeters. That is what Atlas achieved. At the Jet Propulsion Laboratory, orbital analysts mapped its interactions in detail. When extrapolated across time, the resonance became uncanny. The object's course seemed to weave itself between the gravitational fields of the inner planets with an elegance that no natural body could sustain. Its flyby distances were close enough to gather momentum, yet never enough to destabilize or fracture. It was as if Atlas knew the gravitational tides before encountering them, steering its path like a conductor guiding an unseen orchestra. Venus was first. In late August, Atlas slipped past its orbit, its luminous signature briefly brightening as sunlight scattered through the haze of the Venusian atmosphere, a faint glimmer that telescopes on the night side of Earth barely caught. Then came Mars. By early October, it grazed the edge of the red planet's orbital corridor. Probes circling Mars Maven, ExoMars, even the aging Odyssey detected subtle fluctuations in the solar wind, minute anomalies that coincided exactly with Atlas's proximity. Small magnetic irregularities, easily dismissed, but together painting a pattern of interaction. Then came Jupiter, the giant. The planet's immense gravity well is a sculptor of orbits, a judge of trespassers. Countless comets have been torn apart by its invisible tides. Yet Atlas sailed past, unscathed, unbent, as if its trajectory had accounted for the Jovian pull-down to the last decimal. The precision was surgical, no precession, no chaotic deviation, just smooth passage through the storm. When the data was published, one figure haunted every calculation: the resonance ratio. The intervals between these planetary encounters were separated by near-perfect multiples of orbital harmonics, timings so regular they resembled a sequence. Some began to wonder if Atlas's flight path had been tuned, like the notes of an instrument, to use each planet's gravity not by accident but by design. This wasn't new in theory. Humanity itself had used gravity assists, the slingshot technique, to propel spacecraft across the solar system with minimal fuel. Voyager, Cassini, New Horizons, all had danced between planets, stealing motion from their orbits, but Atlas was not one of ours. It came from nowhere, following a pattern that mirrored our own methods, executed with an accuracy beyond human navigation. If Atlas was natural, then it was the universe itself, reenacting our ingenuity, a cosmic echo of our own ambition. But if it was not, then we were witnessing a maneuver of breathtaking sophistication, planned centuries or millennia before we were here to notice. The alignment with invisibility was the cruelest twist. During its closest approach to the Sun, Atlas passed into a position that rendered it unobservable from Earth, hidden by the glare of daylight, masked by geometry. The moment it should have revealed its deepest truths, it vanished behind the star that defined our very existence. Astronomers could do nothing but wait for its re-emergence. The alignment was so exact that it felt theatrical. "Too perfect," muttered Dr. Nystrom during a press briefing. "Too deliberate. If nature did this, it has a sense of irony." When Atlas finally emerged from solar conjunction weeks later, its light curve carried no sign of the expected fragmentation or mass loss. It had endured the sun's furnace unbroken. But the timing, that silent clockwork rhythm, remained the story's heartbeat. Astrophysicists began comparing the data to the trajectories of Oumuamua and Borisov. Neither had exhibited such precise planetary resonances. Atlas alone seemed to know its marks on the cosmic stage. One orbital analyst from the European Southern Observatory put it bluntly, "It's as if Atlas threaded the solar system with a needle thinner than probability itself." In some quarters, speculation grew philosophical. Could gravitational alignments act as a message, an encoded pattern legible only to civilizations advanced enough to decipher it? After all, geometry is the one universal language. Perhaps the pattern was not propulsion but communication, an arrangement meant to draw attention. Others countered with caution. Random processes can produce beauty. Cosmic symmetry can be an accident of chance multiplied by infinity. The universe, vast and patient, does not need intention to astonish us. And yet, every time the models ran, the outcome was the same. The probability curve lay flat, the odds microscopic. Atlas's path fit into the solar system's architecture like a key sliding into a lock. For the watchers who had followed it since discovery, the pattern felt intimate. It was as if the cosmos had orchestrated a performance, a silent choreography across planetary lines, timed to perfection. Whether by chaos or consciousness, no one could tell. But the dance was real. And somewhere, beyond numbers and orbits, an unspoken thought began to take shape. If the universe is indeed a symphony, then Atlas was not noise, it was music. By the time Atlas slipped beyond Jupiter's shadow, it had already shaken the foundations of celestial mechanics. But what came next, the analysis of its composition, threatened to unsettle something deeper, the very chemistry of the cosmos. Spectroscopic readings began arriving in the final weeks of autumn, passed through the cold eyes of telescopes stretched across continents. The Very Large Telescope in Chile, Keck in Hawaii, and ALMA's radio arrays all trained their gaze upon the visitor's spectral fingerprint. And in those fragile bands of color, hidden between the noise of stars, the data whispered a disquieting truth. Atlas was not made like anything else we knew. The lines of nickel and iron glowed sharper, stronger, and denser than any natural comets ever recorded. At first, it seemed impossible, a calibration error, perhaps contamination. But cross-verification only deepened the riddle. The nickel-to-iron ratio was strikingly high, far beyond the cosmic norm. Where typical comets mirror the proportions found in primordial dust remnants of the solar system's birth, Atlas shimmered with a metallic fingerprint that looked manufactured. In the cosmic language of elements, that ratio is not trivial. It tells a story of formation, how deep within stellar furnaces metals condense, how collisions melt and remix their cores. But Atlas's spectrum sang of alloys, not of ores. It resembled the ratios found in terrestrial alloys, forged metals, balanced compositions, ratios that exist not because of chance, but because of purpose. Scientists blinked at the data as if they had glimpsed a ghost. Natural objects, especially comets, are dirty ice carbon, silicates, traces of metal dust bound by frozen water. Their albedo is dark, their structure fragile, ancient, porous. But Atlas's reflectivity and composition hinted at something dense, compact, and possibly metallic on a scale no comet could sustain. It was, as one paper phrased with clinical restraint, incompatible with standard cometary mineralogy. The phrase spread like a quiet confession. Could it be that this was simply a rare type of interstellar metal asteroid, an object born from the shredded core of a long-dead planet? Perhaps, said some, it was a planetary remnant, its mantle stripped away by cosmic violence, leaving behind a gleaming skeleton of nickel and iron. There are analogues, the asteroid Psyche, for instance, which orbits between Mars and Jupiter, a metallic survivor of planetary trauma. But even that comparison faltered. Psyche's ratio of nickel to iron is predictable, adhering to the equilibrium of natural smelting under pressure. Atlas's was unnaturally precise, with ratios rounding into clean fractions as though following design constraints rather than thermodynamic chaos. Dr. Sato, one of Atlas's earliest discoverers, described the moment she saw the data. "I've looked at spectra all my life. I know what randomness looks like, the jagged noise of natural formation. Atlas's spectrum was ordered. It looked crafted." When her remark leaked into the media, headlines ignited. Crafted was the word they chose, though she had meant it metaphorically, but perhaps she hadn't. Across laboratories, the discussion shifted from what Atlas was to how it could exist. The amount of metal implied density far beyond that of a comet, perhaps even beyond that of solid nickel-iron meteorites. Some began to consider hollow structures again, thin shells of reflective metal capable of generating misleading density readings. The idea sounded absurd, and yet the numbers seemed to invite absurdity. Adding to the mystery was the polarization pattern of its reflected light, extreme and negative, twisting the orientation of photons in a way that natural rough surfaces simply do not. It was as though Atlas's skin was smoother than any rock, glossier than any dust. Some likened it to polished chromium, others to titanium composites. Words borrowed from engineering began to invade the lexicon of astrophysics. By mid-October, a working group within the International Astronomical Union convened to reassess the classification of Atlas. The debate was fierce. Some demanded restraint, insisting it remain a cometary body with unusual metallic content. Others quietly argued for a new term altogether, technosignature object. The latter was struck from the minutes before publication, but its ghost lingered in the margins. Avi Loeb, ever the provocateur, added fuel to the fire. In a lecture broadcast from Harvard, he posed the forbidden question plainly. If a civilization wanted to send a messenger between the stars, how would we expect it to look after 1,000,000 years of travel? Would it not appear exactly as Atlas does now, a weathered metallic fragment, gleaming in sunlight, masquerading as a comet? Silence followed his words. The room knew he was courting controversy, but there was something undeniable about the imagery, a shard of technology worn smooth by eternity, mistaken for a natural wanderer. Others, desperate to anchor the mystery in science, proposed more conventional models. Some argued for industrial pollution in the star system from which Atlas came, perhaps a remnant of a planetary civilization that had long since died, its metallic waste scattered into space. Others imagined the collision of two metal-rich planets whose fused debris escaped their dying star's pull. And yet, even those who resisted exotic explanations admitted the data did not fit. Every natural hypothesis required exceptions, conditions stacked upon coincidences until they buckled under their own improbability. The metallic enigma reached beyond astronomy. Philosophers, poets, and journalists began to treat Atlas as a mirror, a reflection of our own longing for meaning amid the void. Was it possible, they asked, that we would only recognize intelligence when it looked like our own craft, our own metallurgy, our own symmetry? Could Atlas be both natural and profound, a lesson from the cosmos that even chance can imitate intention? Still, the data refused to yield. The ratio remained, perfect and cold, carved into the light of a distant traveler. And in that perfection, scientists felt something disquieting, the sense that the universe had spoken not in equations, but in engineering. If Atlas was a comet, it was a comet built by laws we do not yet understand. If it was a relic, then it carried with it the metallurgy of another world. And if, by some impossible truth, it was neither, if it was instead what it appeared to be, then humanity had already received its first artifact from the stars. It gleamed against the blackness, defying the quiet statistics of nature, whispering through its spectral code. You are not the only ones who build. In the common lexicon of astronomy, comets are called dirty snowballs, remnants of creation's earliest chill, made mostly of frozen water, carbon dioxide, ammonia, and dust. When they approach a star, heat wakes them from slumber, and their ice becomes vapor, trailing luminous tails that arc away into sunlight. But as the instruments turned toward Atlas, the readings told a different story, a story devoid of water, devoid of life's ancient whisper, devoid even of the fragility we expect from such travelers. The early spectroscopic data had already hinted at this absence. Hydrogen lines, the telltale indicators of water dissociation, were weak to the point of vanishing. The mass fraction of water, normally the beating heart of a comet's composition, measured at barely 4%, a number so low it should have been impossible. The rest of Atlas's structure appeared to be mineral, metallic, refractory, a mountain of rock and alloy where ice should reign supreme. To visualize it is to imagine an iceberg made almost entirely of stone, an ancient shard that had forgotten how to melt. Astronomers stared at the data with growing disquiet. A comet without ice was not a comet at all. It was a contradiction wrapped in orbit. Dr. Kailia Sato, who had first logged the object, described her reaction later in a paper's margin. If Atlas is a comet, it is one that refuses to burn. If it is not, then we have no name for it. The finding shattered more than definitions, it shattered expectation. Comets, after all, are more than frozen stones, they are archives. Each one carries within it the chemistry of the early universe, the blueprint of planetary birth. Their tales are the fingerprints of creation itself. But Atlas, stripped of ice, was a closed book, a body that refused to reveal what it remembered. As the object approached the sun, researchers waited for outgassing those jets of vapor that burst from subsurface pockets when ice meets sunlight. None appeared. Even the infrared spectra from SOHO's instruments, capable of detecting trace water molecules in vapor form, returned nothing. Atlas remained silent, sealed, inert, in defiance of its proximity to fire. This anomaly wasn't merely curious, it was theoretical heresy. A comet cannot accelerate without ejecting mass, cannot brighten without sublimation. Yet Atlas did both. It glowed fiercely blue, it shifted in trajectory, but it shed nothing detectable. The mathematics of conservation trembled. Perhaps, some thought, it was coated in a refractory crust, a mineral armor that trapped vapor beneath. Yet if so, internal pressures should have shattered it long before perihelion. Others proposed exotic ices, noble gases like neon or argon, that could sublimate invisibly, but even those would leave thermal traces, spectral ghosts. None were found. So, what was this dry traveler, this object immune to evaporation? A few theorists suggested that Atlas might not be solid in the conventional sense. Its apparent density, inferred from brightness and motion, could hide porosity, a vast internal lattice, a sponge of metal and silicate, perhaps even hollow chambers. Such architecture could allow it to store and release energy in ways unfamiliar to us. The idea bordered on science fiction, yet every conventional theory collapsed against the walls of the data. The absence of water also raised a deeper, quieter question, one not about chemistry but about origin. Water is not merely a molecule, it is a storyteller. In the solar system, it binds the outer worlds, fills the void with possibility. Beyond, its presence marks systems where planets form in harmony between heat and cold. To find an object so utterly dry was to find something born from a different kind of furnace, a place where ice never formed, where creation itself may have followed alien rules. Some scientists turned to exoplanet studies for analogues. Could Atlas be a fragment from a system orbiting close to a massive, volatile star where temperatures scoured away every trace of volatile compounds. Such a world would be barren, metallic, cruel, a planet of smoke and storms whose shattered remains fled into the interstellar dark. Others pushed the speculation further. What if Atlas's dryness wasn't inherited, but intentional? If the object were designed, perhaps the absence of ice was no accident, but a necessity. Ice sublimes, corrodes, weakens structure. A vessel meant to endure cosmic time would avoid such fragility. A machine, or a monument, would be made of sterner stuff. Avi Loeb again found himself at the center of controversy. In an interview, he remarked, "If you want to survive the journey between stars, you build from metal, not from ice." The comment drew sharp rebuke, yet beneath the criticism lay a quiet fascination. The metaphor was too. Apartment nature builds beauty through chaos, but endurance demands intention. Meanwhile, the polarimetric data deepened the riddle. Light reflected from Atlas was not just polarized, but negatively polarized to an extreme degree. That meant its surface scattered light backward, twisting the polarization plane, a property observed in finely engineered surfaces, not porous dust. The dry composition and the strange light behavior seemed to reinforce one another. The absence of water also implied another mystery. Comets lose mass dramatically as they near stars. They shed fragments, form debris clouds, sometimes disintegrate altogether. Atlas, by contrast, seemed eternal. No debris cloud shadowed it. No faint tail of dust lingered behind. It was immaculate, a traveler untouched by decay. As months passed, this absence became its own kind of presence. Astronomers began referring to it as the stone that breathes light. Philosophers wrote essays about purity and permanence. The public, hungry for meaning, saw in Atlas the symbol of endurance, something that crossed the abyss without thirst, without loss, without surrender. But in the sterile light of observatories, the implications were darker. A comet that breaks the thermodynamic covenant, that brightens without burning, that moves without mass loss, this is not simply an anomaly. It is a challenge. It tells us that our understanding of cosmic matter is incomplete, perhaps provincial. And yet, for all its strangeness, Atlas remained heartbreakingly beautiful. When telescopes captured its spectrum near perihelion, the color was pure cobalt, a hue impossible for frozen gas, but perfect for refracted light through metal or crystal. Some said it looked like the frozen heart of a star. Others, like a beacon built to last until galaxies fade. Water had been our measure of life. Atlas taught us to look beyond it, for maybe, somewhere out there, life or something greater builds not with the softness of water, but with the permanence of stone. In the silent data streams, in the dry numbers that described its motion, Atlas whispered a new kind of creation myth, not of oceans and clouds, but of heat and endurance, of a universe that remembers how to forge eternity without ever once needing to freeze. By late autumn, when the world had already grown accustomed to Atlas's defiance of gravity, temperature, and logic, a quieter revelation emerged, one that struck not through spectacle, but through the soft, stubborn precision of light. It began with the polarization data, the subtlest of measurements, invisible to the human eye but unmistakable to the instruments built to read the universe's faintest whispers. When sunlight bounces off an object, it becomes polarized. Its waves orient in specific directions, depending on the surface texture and material. Rough, dusty comets scatter light chaotically, their polarization angles consistent across all observations. Smooth metallic bodies polarize differently, often weakly, sometimes positively, depending on reflection angles. But Atlas did neither. Its light was negatively polarized, and to an extreme degree never recorded in any natural comet, meteor, or asteroid. The magnitude of this inversion was not only rare, it was alien. Dr. Elara Nystrom summarized it in the simplest of words. It's as if the light refuses to behave. When plotted on graphs, the measurements formed a pattern like an echo from another geometry. Normally, polarization curves flatten near zero as comets approach the Sun, signifying scattered, uncoordinated reflection. Atlas's curve plunged deep into negative territory, meaning that instead of scattering light randomly, it twisted it backward, bending the plane of polarization as though the photons themselves were being reoriented by something coherent. At first, this result was met with incredulity. Teams recalibrated instruments, checked alignment, reprocessed raw data, but every telescope, from Chile to Hawaii, saw the same ghostly inversion. Atlas wasn't just reflecting sunlight, it was manipulating it. Some described the effect poetically. The object seemed to wear a cloak woven from the sun's own light, bending photons into obedience. But for physicists, the implications were concrete and disturbing. Negative polarization of such intensity requires microscopically uniform surfaces, not rough grains, not porous rock. The object's skin had to be smooth on a scale smaller than the wavelength of visible light. In other words, the entire surface behaved like a single, coherent mirror, thousands of meters across, a mirror with a texture so precise that no known natural process could sculpt it. And yet, there it was turning through the void, dressed in the physics of impossible reflection. At the European Southern Observatory, one researcher compared the polarization to that of nanostructured materials, like those used in metamaterials or photonic crystals on Earth substances engineered to control light in unconventional ways, bending it, delaying it, twisting it through sub-wavelength lattices. The similarity was eerie. It's not that it is artificial, he said cautiously, but it behaves as if it could have been. This behavior also dovetailed disturbingly well with Atlas's other anomalies. Its reflective metal ratios, its dryness, its non-gravitational acceleration, all of them pointed toward a surface capable of interacting with radiation pressure in abnormal ways. Could this twisting of light be part of the mechanism propelling it? If Atlas's skin manipulated light so completely, then sunlight itself could act upon it not as random heat, but as controlled force, a sail shaped by polarization. Perhaps the negative polarization was not an accident, but a byproduct of function. For Avi Loeb and a growing number of independent theorists, this was more than coincidence. They posited that Atlas might represent an extreme form of light sail, its structure composed of engineered materials able to reflect, refract, or even absorb photons in patterns that produced thrust. The negative polarization could then be evidence of a technology so advanced it transcended the limits of efficiency imagined by human physics. The mainstream scientific community pushed back, reluctant to let such speculation breach peer-reviewed journals. But the data remained unyielding, an elegant signature written across the electromagnetic spectrum. Each wavelength, each angle of observation told the same story. A surface too perfect, too coordinated. And perfection in nature is always suspicious. As the object drifted further from the Sun, its brightness oscillated in periodic intervals, subtle pulses every 31 minutes. The variation was small, almost lost in noise, but consistent. Some suggested rotational modulation, but others noticed something stranger. The polarization angle itself seemed to shift in sync with the brightness, as though the object were not simply spinning, but dynamically altering how it interacted with light. To the poetic mind, it resembled a heartbeat, the pulse of a silent mechanism breathing energy into motion. To the skeptic, It was an illusion of data smoothing. Yet even skeptics grew quiet when the pulse remained steady for months, defying random fluctuation. In darkened observatories, the pattern of Atlas's light became a kind of liturgy. Researchers stared at screens, watching numbers rise and fall in rhythmic defiance of explanation. Some whispered that it felt alive. Others countered that life had nothing to do with it. This was geometry, not biology. But deep down, both camps shared the same quiet awe. Whatever Atlas was, it was self-consistent. Every anomaly reinforced another, as though the universe were building a riddle one layer at a time. There were philosophical ripples, too. If Atlas could twist light so elegantly, perhaps the laws of optics were broader than our textbooks allowed. Perhaps matter could be arranged in ways that rewrite the behavior of photons, bending them without lenses, shaping them without mirrors. And if so, what else might be possible? A few speculative physicists went further, whispering that Atlas might even manipulate quantum coherence, that the photons reflecting from its surface were entangled, maintaining orientation over vast distances. If true, it would represent not just engineering, but understanding far beyond humanity's reach. Whatever the explanation, Atlas seemed to speak a language made of light, each reflection a syllable, each shift a word in a vocabulary we could not yet read. It was as though the object had wrapped itself in a paradox. To reveal its nature, one had to look, yet to look was to be deceived by the very light it controlled. In that paradox, Atlas became something more than a scientific mystery. It became a metaphor, a mirror, not just of the sun, but of humanity's hunger to see and understand. Because perhaps what frightened us most was not that Atlas could twist light, but that it twisted truth, reminding us that what we see is never quite what is there. As December approached, and Atlas prepared for its closest approach to Earth, astronomers began to ask the question quietly, almost reverently. If light itself bends around Atlas's will, what will happen when that light touches us? By early November, as Atlas continued its measured drift toward Earth's orbit, a deeper cosmic coincidence began to surface, one that stitched the present to one of astronomy's most haunting mysteries. When its incoming trajectory was projected backward through the interstellar dark, the numbers converged on a particular corridor of the sky. Not a constellation, not a named nebula, but a direction with a legend, the region of the 1977 wow signal. For those who have studied the long silence of the cosmos, that name carries gravity. On August 15th, 1977, a narrowband radio transmission, brief, precise, and powerful, was captured by Ohio State University's Big Ear radio telescope. It lasted 72 seconds. It matched the mathematical signature of something artificial, and then it vanished forever. Its source, a small patch of sky near the constellation Sagittarius, devoid of any known transmitters, any stars, close enough to shout that loud. The printout from that night bore a handwritten exclamation, "Wow!" Now, nearly 50 years later, Atlas had come from almost the same celestial neighborhood, within 9 degrees of that enigmatic coordinate. In cosmic terms, that proximity was intimate, as if two notes from different centuries had been played in the same bar of a universal melody. Statistically, the overlap meant little. The Milky Way's breadth is generous enough for coincidence. But emotionally, philosophically, it was impossible to ignore. Astronomers who had grown up reading about the WOW signal now found themselves tracking a luminous visitor from that same quadrant, one that defied physics as the signal had defied noise. The whispers began quietly, conference hallway murmurs, side comments in peer-reviewed drafts. Could the two phenomena be linked? Not causally, perhaps, but narratively, the echo of a pattern that had waited half a century to repeat itself in a different form of language. Dr. Avi Loeb, careful as always, refused to indulge fantasy, yet even he acknowledged the poetic symmetry. Science, he said during a panel discussion, advances not by certainty, but by curiosity. The coincidence may be nothing, or it may be the universe clearing its throat again. Others were less restrained. Some theorists suggested that if the WOW signal had been a deliberate broadcast, Atlas could represent a physical counterpart, a messenger launched from the same civilization that had once tried to speak in radio. A probe, perhaps, designed to follow its signal, arriving centuries or millennia later. This idea was speculative in the extreme, but it carried an eerie elegance. Light and matter, communication and embodiment, two expressions of the same intent, separated by time but aimed toward the same cosmic audience, humanity. To entertain the thought was to step beyond science and into mythology. Yet every detail of Atlas seemed to encourage such leaps. Its impossible trajectory, its metallic composition, its anti-tail, its defiance of entropy. All of them fit too neatly into a narrative we both feared and desired that something out there had once looked this way, toward us. At the SETI Institute, interest quietly reignited in the old coordinates. Dishes once silent turned again towards Sagittarius. A small team began cross-referencing historical data from the 1977 event with modern telemetry from Atlas's flight path. The geometry was uncanny. Both seemed to intersect along a line that, when extended, crossed the galactic plane at nearly the same declination. Coincidence, again, but the kind that pulls at the human mind like gravity itself. Even skeptics could not resist the resonance. The WOW signal had been a mystery of information, a coded moment of structured order emerging from noise. Atlas was a mystery of matter, an object of structured order emerging from chaos. Both were signals of different mediums, one ephemeral, one enduring. Public imagination seized the connection immediately. Media outlets framed Atlas as the sequel to the WOW signal. Artists composed pieces named The Second Hello. Philosophers wrote that perhaps the universe's communication was not a conversation, but a recurrence, ideas returning, not in words, but in echoes of structure and light. And yet, even as the narrative bloomed, the scientists at ALMA and Keck remained anchored in numbers. The spectral line from Atlas's origin direction matched the galactic background perfectly. No radio emissions, no beacons. Silence, as ever. The void had spoken once in radio and had since fallen quiet. If Atlas was an answer, it was written in motion, not sound. Still, that silence felt different now. It was not absence, but waiting. In late November, a joint statement from the International Astronomical Union attempted to dispel speculation. There is currently no verifiable evidence linking the trajectory of 3 Atlas to any prior extraterrestrial signal. Yet, even that denial read like a confession. The wording admitted the thought existed. The door remained open, if only a crack. Somewhere in the deserts of New Mexico, amateur radio astronomers tuned their dishes once more to the old coordinates, listening for that narrow 1,420 MHz hydrogen line, the universal frequency of curiosity. Most nights, they heard nothing but the soft hiss of cosmic background radiation. But once, in mid-November, one observer reported a faint, momentary spike. Too weak for verification, too brief to claim discovery. He logged it anyway. One pulse, he wrote, in the same band as the original. No one can prove it was real, but no one can prove it wasn't. As Atlas approached its December rendezvous with Earth, its origin in that haunted sector of sky remained the most tantalizing of coincidences. Perhaps it had simply been born there, flung from a star we had never named. Perhaps the WOW signal was nothing more than terrestrial interference, a forgotten satellite's dying breath. But perhaps, and this word grew louder with each new anomaly, perhaps, the universe had chosen to repeat itself, to remind us that even across decades of silence, across the endless drift of stars, something remembers. Atlas, the third interstellar visitor, the bright and silent wanderer, came from the direction of a voice we once thought we heard. And whether that echo was cosmic chance or cosmic design, it was enough to make humanity, for one fleeting moment, believe that the conversation had never truly ended. When Atlas reached its perihelion, the moment of closest passage to the Sun, astronomers expected it to flare like every other comet before it brightening as solar heat tore apart its fragile surface, erupting in jets of vapor and dust. Yet what unfolded instead was something neither human eye nor instrument had ever witnessed. Atlas did not burn white or gold, it burned blue. Not the soft, icy blue of atmospheric scattering, nor the faint cyan sometimes seen in the tails of ionized comets. This was deeper, an electric, near-ultraviolet radiance that bordered on the impossible. Observatories across the world recorded it independently, their sensors briefly saturating as the object blazed brighter than predictions by several magnitudes. Its hue was so intense, so spectral, that for a few hours, Atlas became bluer than the Sun itself. For the scientific community, that single measurement triggered a quiet panic. Color, in astronomy, is never just beauty, it is physics made visible. Every wavelength tells a story of temperature, composition, and motion. To appear bluer than the Sun means to emit light corresponding to temperatures exceeding 6,000 Kelvin, yet no known mechanism could make a solid body that cold radiate like a star. Unless, of course, it wasn't radiation at all, but reflection or something stranger. Some theorized that Atlas's highly metallic surface might act as a frequency shifter, reflecting light in a way that favored shorter, bluer wavelengths. Others proposed fluorescence, a process in which absorbed ultraviolet photons are re-emitted at visible energies. But the efficiency required to produce such brightness was absurd orders of magnitude beyond any known natural surface. The event became known simply as the Blue Anomaly. The first images came from NASA's SOHO and STEREO spacecraft, whose cameras captured the object's incandescent transformation as it passed the Sunday. Then the ALMA array in Chile followed, observing subtle changes in polarization and brightness as Atlas re-emerged. It had brightened by nearly a factor of 5. Its spectrum shifted hard toward the blue, and its apparent size remained eerily stable. The data, when translated into numbers, suggested an impossible balance. The object had gained brightness without expanding its coma, without shedding visible dust. In other words, Atlas glowed brighter without losing anything. This was not how nature works. Luminosity costs mass, and beauty costs decay. Yet here was a body that seemed to defy entropy itself, a self-contained radiance. Dr. Ilara Nistrom described it with quiet reverence. It shone like a promise that didn't need fire. The anomaly rippled through the scientific world like an aftershock. Teams in Japan and Italy proposed that Atlas's surface might contain quantum metamaterials, theoretical composites capable of altering photon energy through resonance. Such structures, if they existed, could upconvert sunlight, absorbing lower energy wavelengths and re-emitting them in blue. It was a technology humans had only begun to imagine in laboratories. The idea that nature had invented it first felt almost blasphemous. Yet there was something else about that blue. Witnesses who saw it through filtered telescopes described it not as static light, but as alive, flickering in pulses, like a heartbeat. The oscillation matched the same 31-minute interval observed earlier in Atlas's brightness variations. The timing was too precise, too persistent to be coincidence. It was as if the object had a rhythm, an internal metronome syncing with its luminous breath. The media seized on it, calling it the heartbeat of Atlas. Philosophers called it the pulse of the cosmos. But for physicists, it was a signal, a modulation that might carry information. Spectral analysis of the blue flare revealed fine, evenly spaced emission lines superimposed on the continuous spectrum, almost like harmonics. Some dismissed them as instrumental artifacts. Others whispered a different word, encoding. SETI, revived by the object's origin near the WOW signal, aimed radio telescopes toward Atlas once more. They found nothing, no narrowband emissions, no deliberate transmissions. Yet some wondered if the signal wasn't in radio at all, but in light itself. After all, the blue flare had structure, periodic, ordered, recursive. One of the more daring hypotheses came from a small team at Caltech. They proposed that Atlas might act as a solar lens, using the sun's gravity to focus and redirect light from beyond. If true, the blue glow could be a byproduct of gravitational optics, a focused beam from deep space, bent and amplified through solar alignment. In this model, Atlas was not emitting light, but translating it, turning the sun into an interstellar communication relay. The idea was breathtaking and terrifying. It implied intention design on a scale beyond comprehension. Still, there were natural explanations that clung stubbornly to plausibility. The blue could arise from exotic metallic oxides or from plasma emissions triggered by solar magnetic fields. Perhaps Atlas had a core rich in cobalt or titanium, metals that produce blue luminescence under certain ionization states. But even those models failed to explain the absence of heat or mass loss. No dust, no gas, no tail, just blue. And so the debate widened. Was this radiance an act of physics or of message? To the naked eye, filtered through the instruments of science, Atlas's blue glow was more than color. It was emotion rendered as energy. It called to something primal, the same way ancient mariners once looked at stars and felt both awe and dread. For humanity, that shade of blue became a mirror. It was the color of distance, of oceans and atmospheres, of home viewed from afar. Some said it was the color of intelligence itself, the hue of something that knows how to make light without flame. As Atlas moved away from perihelion, its brightness faded gradually, but the blue never vanished entirely. It lingered in its reflected spectrum, a signature of whatever it truly was. The object had shown us its heart and then closed it again, leaving behind nothing but numbers and wonder. In the end, the blue anomaly became not an answer, but an invitation, a moment when the universe lifted the veil just enough for us to glimpse its machinery, then gently pulled it back, reminding us how little we understand of its theater. Somewhere between physics and myth, between data and dream, Atlas glowed blue because it could. And for humanity, that was enough to believe, for one fragile moment, that the stars were trying to speak. By late November, the numbers no longer lied, they whispered. Each observation, each recalculated trajectory, each spectrum, each image of Atlas returned from the great observatories, confirmed what no one had believed possible. The object was accelerating, ever so slightly, and yet showed no measurable mass loss. It was as though some invisible hand was pushing it through the dark. The first to notice was a postdoctoral researcher analyzing data from the Atacama Large Millimeter Array. Comparing positional data from early October to late November, she found the object was off by 4 arcseconds from its predicted course. Tiny, but significant. At that distance, even the smallest deviation required a force measurable in millions of newtons. Something was acting upon Atlas, something beyond the steady pull of gravity. In comet physics, such deviations are common enough. Sublimating gas from melting ice can produce small jets that push a comet slightly off course. But Atlas, as we already knew, had no ice. It had no outgassing, no visible tail, no halo of debris, and to account for this shift naturally, it would have had to shed billions of tons of material, nearly 15% of its total mass. That debris should have lingered as a luminous cloud, scattering sunlight and betraying its presence. Yet the space around Atlas remained pristine. This was the 10th anomaly, and perhaps the most unsettling of them all. Scientists around the world fell into two camps, those who sought a conventional explanation, and those who quietly wondered if they were watching the first demonstration of non-Newtonian propulsion, the kind that belonged to thought experiments, not to nature. The conventionalists argued for asymmetric radiation pressure. Perhaps the surface of Atlas, with its extraordinary reflectivity, was responding to solar photons unevenly, an optical sail turned subtly by geometry. But that explanation required an absurd coincidence of angles and materials. Worse, it could not account for the magnitude of the effect. Radiation pressure diminishes sharply with distance from the Sun, yet Atlas's acceleration remained constant. Others pointed to magnetic interactions. If Atlas possessed a metallic composition and residual magnetic field, it might experience tiny forces as it passed through the Sun's complex magnetic web. But again, the math fell apart. The required magnetic field strength would have been so enormous that Earth-based instruments would have detected its influence directly. They did not. So what was left? A few dared to speak of active control. If Atlas were hollow, if its structure concealed systems capable of harnessing light or magnetism, then the acceleration might not be reactionless, it might be designed. A relic of a long-dead civilization, coasting on the echoes of a forgotten technology. The phrase self-propelled began appearing in private communications and embargoed drafts, never in print. To admit it aloud was to court ridicule. Still, there were clues. The acceleration was directional, not random, not tumbling, not diffused by spin. It followed the same orientation as the object's sunward axis, precisely aligned with the strange anti-tail that had once defied physics earlier that summer. The link was undeniable. Whatever force had produced that anomalous jet seemed now to be whispering again, subtler, steadier. Avi Loeb, reviewing the compiled data, said quietly to a colleague, "If it accelerates without losing mass, it isn't being pushed, it's deciding." No one quoted him publicly, but the words spread anyway. At NASA's Jet Propulsion Laboratory, a simulation was run to project Atlas's future trajectory. Under purely gravitational conditions, it should have followed a predictable hyperbolic arc out of the solar system. But with the observed acceleration factor added, the model diverged. Instead of fading into deep space, the curve bent slightly toward the ecliptic plane, a path that, in time, would intersect Earth's orbital corridor. The proximity wasn't dangerous. The pass would occur at a safe distance of millions of kilometers. But the geometry was haunting. Atlas wasn't fleeing. It was approaching. And so, the debate turned philosophical. Was this an accident, a cosmic fluke, or the manifestation of something we couldn't yet comprehend? Could a natural object, through complex interactions of light, magnetism, and material resonance, produce an effect so cleanly mimicking control? Could randomness so perfectly imitate intention? Every test to detect dust or plasma came back negative. Every instrument that could have revealed a material discharge saw nothing, and yet the acceleration persisted, a ghost thrust. In theoretical circles, some resurrected the concept of Mach's principle that motion itself might be influenced by the distribution of mass in the universe. Others invoked quantum vacuum fluctuations, the idea that empty space is not truly empty, and that a sufficiently exotic material might draw momentum from the energy of the vacuum itself. A few even cited speculative work on Casimir propulsion, a hypothetical technology that could convert quantum pressure differentials into thrust. If Atlas somehow embodied such principles not as design, but as material fact, it might be a naturally occurring quantum engine, proof that the universe, in its infinite creativity, had stumbled upon technology long before we dreamed of it. Still, the human mind tends toward meaning, and meaning, once glimpsed, cannot be unthought. The observers could not help noticing that the acceleration seemed timed. It began subtly after the blue anomaly faded, as if one phase of behavior had ended and another begun. The object flared, cooled, then moved. It was sequential, rhythmic, a cause and an effect. If one were to describe it narratively, it was almost as if Atlas had awakened, glanced at the star, and adjusted its course. When the final pre-December telemetry came in, Atlas's velocity had increased by a measurable fraction, small, yes, but unmistakable. Its path had curved, gently, inexorably, closer toward the Earth-Moon system. And once again, the universe forced humanity into a corner of reflection. A comet that accelerates without losing mass does not simply break a law of physics, it redefines the idea of force itself. Because force implies action and reaction, energy and expenditure, cause and effect. Atlas did none of these. It moved, but nothing moved it. It burned, but nothing was consumed. For philosophers of science, this was the ultimate riddle, the paradox of something acting without cost. It was the mathematical echo of life, of consciousness, of will. The headlines called it the thrustless miracle. Scientists preferred non-gravitational acceleration, but the poets, always faster to the truth, gave it another name: the object that chose its path. In every age of discovery, there comes a moment when knowledge collides with belief, when evidence sharpens into heresy, and science, against its will, stares into the mirror of its own limits. For Atlas, that moment arrived long before its December approach. It arrived in the minds of those who had dared to interpret its silence. The world had split. On one side stood the theorists, those who believed that what we were witnessing was not an aberration of physics, but a message written in matter. And on the other, the doubters, guardians of orthodoxy, who clung to equations like shields against the encroaching storm of imagination. Between them stretched the glowing trail of Atlas, an object neither side could fully claim. At the center of the storm was Avi Loeb, the Harvard astrophysicist who had, years earlier, raised eyebrows by suggesting that Oumuamua, humanity's first interstellar visitor, might have been artificial. Now, Atlas had arrived, and every anomaly seemed to vindicate his once radical stance. In lecture halls and interviews, his tone was calm but quietly defiant. "When evidence defies theory," he said, "it is not the evidence that must yield, it is the theory." To Loeb and his collaborators, Atlas represented the culmination of a pattern. First, Oumuamua, small and fleeting, then Borisov, natural and comforting, now Atlas, immense and deliberate. Each an escalation, each tightening the thread that bound observation to meaning. In his view, the acceleration without mass loss, the metallic reflectivity, the impossible blue brightness, all pointed toward a technological relic, not a cosmic accident. Perhaps it was a probe, perhaps a derelict sail, abandoned eons ago by a civilization that no longer existed. Or perhaps something older, built not to communicate, but to endure, a testament left behind by intelligence that understood entropy as poetry. To others, this was fantasy masquerading as hypothesis. Dr. Kailia Sato, whose discovery logs had first captured the object, publicly disagreed. To leap from data to intention, she said in a restrained press statement, is to mistake mystery for message. Nature is strange enough without our help. Her words resonated with the cautious majority. After all, history had shown the danger of premature conclusions. The canals of Mars, once thought to be alien aqueducts, were illusions of light and desire. The signals from pulsars were first called LGM, little green men, before turning out to be the heartbeat of dead stars. Even the WOW signal itself could have been a terrestrial ghost, a radio reflection from our own machines. And yet, Atlas was not so easily dismissed. Because unlike signals or sightings, it was there a physical thing, measurable, observable, undeniable, no mirage, no static, and that made it infinitely harder to explain away. As debates raged in scientific journals and televised panels, the tone shifted from skepticism to unease. The European Space Agency proposed an impromptu observational campaign, a coalition of observatories across the globe to gather as much data as possible during Atlas's December flyby. Privately, several physicists argued for the unthinkable, to attempt radio contact. If the object was indeed a vessel, they reasoned, it might be listening. The proposal was quietly buried before it reached any official channel. No one wanted to risk humanity's first greeting being a cry into the void. Still, the questions multiplied. Could Atlas truly be artificial? If so, who had sent it and when? Given its interstellar trajectory, it might have been launched millions of years ago. Civilizations rise and die in less time than that. If it carried intelligence, it might be long extinguished. What we observed could be not a messenger, but a monument, drifting through eternity, indifferent to the eyes that now beheld it. Philosophers began to write of Atlas not as an object, but as a mirror, a test of how humanity perceives mystery. Some argued that our interpretations reveal more about ourselves than about the thing we study. If we see technology, perhaps it is because we long for company in the cold. If we see nature, perhaps it is because we fear that the universe has no author. Meanwhile, the doubters continued their experiments. A team in Japan proposed a natural model involving anisotropic thermal radiation, the Yarkovsky effect, magnified by Atlas's unusual composition. Another group in Switzerland explored the idea of electrostatic propulsion, generated as solar radiation, ionized its metallic surface. Each paper added nuance, but none closed the case. The data always refused full obedience. And so, the conversation shifted from what Atlas was to what it meant. To the public, Atlas had transcended science. It became myth in real time. Documentaries portrayed it as a cosmic messenger. Artists painted it as a shining obelisk drifting through the dark. Children in classrooms asked teachers whether the alien comet would wave at Earth. And though scientists rolled their eyes, none could deny that Atlas had rekindled something rare, a global awe. In Cambridge, Loeb summarized the situation best. In a letter to a colleague, later published in Nature Astronomy, he wrote, "Whether Atlas is natural or not, it has already served its purpose. It has reminded us that the universe still holds surprises vast enough to humble us, and that humility is the beginning of wisdom." But not everyone found comfort in humility. For some, Atlas represented an existential unease. If it was artificial, then we were not alone. And if it was natural, then the cosmos itself was capable of crafting wonders indistinguishable from design. Either way, humanity was small. The December approach drew near, and with it came a silence that spread across every observatory. Theories gave way to anticipation. For months, scientists had argued across oceans and disciplines. Now, they would simply watch. Because in the end, no debate, no model, no philosophy could change what would soon happen. Atlas would pass close enough for its truth to be seen. And whatever that truth was, technological or cosmic, conscious or inert, it would redefine not only our understanding of physics, but our understanding of ourselves. For centuries, we had looked at the night sky and asked, "Are we alone?" Atlas did not answer. It only approached, indifferent, patient, shimmering with the light of something that refused to be named. By the first days of December, the world had fallen silent. News anchors spoke softly now when they said its name, Atlas, as though it were no longer an object, but a presence. Across observatories and universities, screens glowed through the night, each pixel a window into anticipation. For months, the story had been argument and wonder, theory and defiance. Now, it was simply waiting. The object would pass nearest to Earth on December 19th, a date that had taken on the gravity of prophecy. On that day, Atlas would glide through the plane of our orbit, its cobalt body reflecting the sunlight that had once birthed its impossible blue flare. The numbers said it would be safe millions of kilometers distant, a ghost touching nothing. But proximity is not measured in distance alone. The world felt close to it, as though something immense was about to look back. The ALMA array, the James Webb Space Telescope, and dozens of ground-based observatories had all been synchronized for the encounter. Even amateur astronomers prepared, calibrating lenses, writing scripts to track its passage. Humanity, scattered across continents, stood under the same sky, watching for a single speck of light. The first images arrived early on the morning of December 18th. Atlas shimmered against the blackness, steady, serene. No debris cloud surrounded it. The void was immaculate. The dreaded dust that should have followed an object shedding 15% of its mass was nowhere to be found. The 10th anomaly was confirmed. A comet that accelerates without losing mass. An equation that dares the universe to explain itself. And still, there was no sound, no signal, no gesture, only motion, only grace. In Cambridge, Avi Loeb looked over the final telemetry and smiled without triumph. "We always hoped the unknown would speak," he said. "Perhaps this is what it sounds like when it simply moves." For all the fear and fever of speculation, there was also beauty. Atlas had forced the human mind to stretch, to imagine physics beyond its comfort, to question its own assumptions about intelligence and intention. It had become a mirror through which our species saw its own hunger, not for contact, but for comprehension. In the final hours before the encounter, as the Earth rotated into darkness and the last observatories took their shifts, the world seemed to hold its breath. The night was thick with data and prayer. Somewhere above, an object born or built beyond the reach of human history drifted past our planet, blue and silent, obeying no law we understood. No message came, no flare of light, no deviation, no sign. Atlas passed quietly, its velocity unwavering, its path serene. It left behind no proof, only questions. But even in that stillness, something shifted. Because for all our science, all our skepticism, and all our cynicism, we had looked into the cosmos and found something we could not name. We had glimpsed the edge of comprehension and discovered awe again, raw, wordless, ancient awe. When dawn came, telescopes continued to track Atlas as it began its slow departure, fading into the black. It was leaving us, but not truly. Data would be analyzed for years. Arguments would continue for decades. Children would grow up remembering that December when Earth turned its eyes skyward and saw a light that shouldn't have existed. And in the silence that followed, a thought lingered, gentle, persistent, impossible to ignore. Perhaps Atlas was not meant to be understood. Perhaps it was not a visitor or a message at all. Perhaps it was a reminder that the universe is still wild, that discovery is not the end of mystery. That knowledge, no matter how complete, will never replace wonder. And so the story closed the way it began, with light. A single perfect blue gleam, receding into forever, whispering that truth is not always an answer. Sometimes it is a direction. The night after the flyby, the world slept differently. Across mountains and deserts, the telescopes turned away, their lenses cooling in the hush of winter. The data streams slowed to silence. Yet somewhere, in the black ocean of space, Atlas drifted on an ember from another dawn, carrying questions too vast for words. Scientists wrote their reports, philosophers wrote their doubts, and the rest of us looked up at the sky, knowing that something extraordinary had passed us by, something that had not asked to be seen, only to exist. The equations would one day grow simpler, the models cleaner, the anomalies resolved or forgotten, but the feeling would remain, that thin, electric trembling between wonder and fear, that reminder that the cosmos still holds secrets we cannot measure, only feel. Perhaps that is the true gift of Atlas, not revelation, but humility. It reminded us that every answer is temporary, every certainty fragile. It asked us to listen again, not for voices, but for silence, for movement, for the faint pulse of light that drifts through eternity without explanation. And somewhere, in that silence, perhaps the universe smiled, patient, eternal, unbothered by our confusion. For in its infinite theatre, we are still the audience, still the dreamers who mistake curiosity for meaning and meaning for proof. But the cosmos does not mock us. It waits. It invites. And as Atlas faded into the dark beyond Neptune's cold orbit, the world exhaled, carrying with it a quiet, luminous truth. We are not alone in mystery. We are part of it. Sweet dreams.